Everybody. Now we're going to start chapter 2. And section 2.1 deals with frequency distributions and their graphs. Oops. I really hope that you will follow through with this whole video, as I'm going to be showing you some calculator steps, things that will make your life easier. And again, we'll be adding some things that you may not necessarily see in the interactive things on your Moodle. So let's first talk about what a frequency distribution is. A frequency distribution is a table that shows classes, that shows data divided into classes of entries with a count of the number of entries in the class. In each class. So we're going to go through the steps that you'll need to complete to create a frequency distribution table. Step 1 is to determine the number of classes. Most of the time this will be given to you by the author, either by myself on your lab or on your homework. Pearson will actually probably indicate the number of classes they'd like for you to use. So once you know how many classes, you'll need to determine the class width. You'll do this by taking the range, and range is the max minus the min, and dividing that by the number of classes. Once you've done that, you need to round up to the nearest whole number, or to the next whole number. So once you've determined the class width, the next thing that you'll need to do is to actually create your classes. You're going to start with the minimum value. And this will be the lower limit of the first class. Then you will add the class width to get the next class lower limit. You'll repeat this process until you have the number of classes specified. Then the last thing you'll do to get the upper limit of each class reduce the next class's lower limit by 1. For example, let's say my minimum value of a data set was 9 and my class width was 12 and I had 5 classes. Then I would start with 9, add 12 to 9 and get 21, add 12 to that and get 33, add 12 to that and get 45, add 12 to that and get 57. And I have my 5 classes. So this first would be, these are all my lower limits. And so if I decrease the next lower limit by 1, that gives me 20. So that means 20 is my upper limit for my first class. That would make my second class upper limit 32. My next class upper limit 44. My next class upper limit 56. And you can see you're adding 12 each time to get the lower limits. You'll also see that it adds 12 each time to get the upper limits once you have the first one. So 20 plus 12 is 32, plus 12 is 44, plus 12 is 56. So to get the last upper limit, 56 plus 12 would be 68. And that would give you your classes. So that's the steps that you go through to get your frequency distribution table classes. Once you have the classes, then you will need to use the data to count the frequency of data pieces that fall in each class interval. So, I'm going to give you an example. These are prices of 30 portable GPS systems. 30 portable okay, so we've got 128, 340, 230, 230, 140, 100, 105, 150, 200, 112, 180, 85, 150, 110, 90, 150, 270, 120, 126, 340, 200, 200, 130, 170, 170, 90, 65, 80, 132, and 190. Now, what I'm going to show you next is a couple of things that you can do on the calculator so that you will not skip over any problems or anything of that nature. So, give me a minute. Choose Edit. Anytime you go into your calculator and you already have data in there, you can hit second plus 4 to clear all the lists. That'll make it a quicker, easier thing, and you won't delete any of your actual lists. So the first thing I'm going to do is actually put the data in. Sorry about all this moving here. So 128, 340, 230, 230. Okay, so I have my 30 pieces of data in. One of the things that I want to show you is how to sort that data so that when you go to counting the number of data pieces in an interval, it doesn't, you don't miss any. So if you go back to Stat, you'll notice that number 2 says sort ascending. And then it's going to open parentheses. You need to tell it what list to sort. So I'm going to hit second 1 for L1, and it'll tell you that it's done. So now when I hit Stat Edit, my data is still there, but it's in numerical order. So going back, so at this point, we do the maximum minus the minimum divided by 5 equals 55. We're always going to round that up, so we'll round that up to 56. So my first lower limit is 65 because that's the minimum. If I add 56 to that, I get 121. That would make the upper limit on my first class 120. If I add 56 to the 121, I get 177, which would make this 176. If I add 56 again, I get 233, which would make this 232. Add 56 again, and I get 289, which would make this 288. And if I added 56 again, I would be at 345, so that makes this 344. So notice that there's 56 between each of the upper limits and each of the lower limits. Now I'm going to count how many data pieces called the frequency fall in each of the classes, and I'm going to do that by going back to Stat Edit and counting my numbers in my list that's already been sorted. So from 65 to 120, including 120 gives me 10. From 121 to 176, I also have 10. From 177 to 232, I have 7. From 232 to 288, I have 1. And from 289 to 344, I have 2. Now, you'll notice that if I add those up, I have a total of 30 data pieces. In addition to a frequency distribution table, we can have something called a relative frequency. Now, to give you a little bit more information, and I'll come back to this, relative frequency is the portion of the whole data set and it is calculated by taking the frequency and dividing it by the number of data. So if I use that definition, this would be 10 divided by 30. So that's 1/3 or 0.33. Same thing here, 0.33. Then 7 divided by 30 is 0.23. 1 divided by 30 is 0.03. And you can leave these in fraction form or decimal form. And then 2 divided by 30 is 0.07. Now, if you total the relative frequency, you should come close to 1. The only reason you wouldn't get exactly 1 is for rounding reasons. So if you look at this, 0.33 plus 0.33 plus 0.23 plus 0.03 plus 0.07, you get 0.99. And if I went out additional decimal places, you would probably get approximately 1. We also want to look at the cumulative frequency. Cumulative frequency, again, let me add that definition for you. Cumulative frequency is the frequency from the beginning to the upper limit of that class. So from the beginning to the upper limit of that class. So if we look at the cumulative frequency up to 120, we get 10. If we look at the cumulative frequency up to 176, you add these two together and you get 20. So I'm going to take the 10 and add the next 10 and I get 20. Then I'll add the next 7 and get 27. So from 65 to 232, there are 27 data pieces. Add the 1, so up to 288, there are 28 data pieces. And then up to 344, there are 30 data pieces. This total and this number should be the same. Then we have cumulative relative frequency, which is the same thing, only dealing with the relative frequency. So up to that point is 0.33. Add in the next 0.33 and you get 0.66. Add the next 0.23 and you get 0.89. Add the next 0.03, you get 0.92. And next 0.07, and you get the 0.99. And then this number and this number should be the same. So that gives you an idea of everything you will find in a frequency distribution table. You'll be asked to find the class width. You'll be asked to create the lower and upper limits of each class, count the frequency that is involved in each class, calculate the relative frequency and the cumulative relative frequency that goes along with each of those. You will find some classes that actually, to calculate the mean and the standard deviation, when given nothing but a frequency distribution table, you'll have to calculate the midpoint of the classes. To find the midpoint of the class, which we'll also do if we're graphing, you would add the upper and lower limits and divide by 2. So in this case, the midpoint of the first one would be 92.5. The next one would be 148.5. The next one would be 204.5. The next one would be 260.5. And the next one would be 316.5. So that gives you each of the frequencies, relative frequencies, cumulative relative frequency, and cumulative frequency. The next thing that you'll be asked to do is to create a histogram. So that's going to be the graph that goes along with this frequency distribution table. If we're dealing with quantitative data, you will use a histogram and the bars will touch. So it's used with quantitative data and the bars touch. The midpoints are often used whenever you're creating the histogram. One of the things that I want to make sure that you do with your histogram is you need to label your axes. You need to give the graph a title. Those are things that you will lose points on for your lab if you don't do. So please make sure that you do these two things. So we want to make a histogram. And we're actually going to do two different ones. I'm going to do a frequency histogram, and then I'm going to do a relative frequency histogram. And what you'll see is they're actually exactly the same. So for my frequency, my numbers go from 1 to 10. So I want to make sure that I use all of those. 1, 2, and they need to be evenly placed on the vertical axis. 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Now, because my first class starts at 65, I'm not starting at 0. I'm going to use this little symbol that kind of means that the graph has been scrunched up. And so my bars are going to, I'll have 5 bars. And I'm going to use the midpoints to label each of my bars. So 92.5, 148.5, 204, 260, and 316. So these are GPS prices. The title would be 30 GPS prices. This axis is frequency. And so I'm going to do my first bar, which goes up to 10. Oops. My second bar also goes up to 10, so I'll go ahead and do that bar as well. My third bar goes up to 7. My fourth bar goes up to 1. And my last bar goes up to 2. And so I now have my histogram of my 30 GPS prices. The only thing that would change if this was relative frequency instead of frequency is my left-hand side, my vertical axis, would be in decimals instead of in actual frequency numbers. So that's the only thing that would change. So that actually takes us on to section 2.2, which is other graphs. And we're going to look at stem and leaf displays. We've already talked about histograms. And we'll also eventually talk about box plots. These are all graphs for quantitative data. Dot plots, scatter plots, time series plots, they are all for, and bar graphs. Are more for qualitative data. Dot plots are sometimes used for quantitative data as well. Actually, let me go through here because scatter plots and time series plots, those are more for bivariate data. So bar graphs, dot plots, and then let me add pie charts. Those are your qualitative data graphs, so you'll see most often. So looking at these, we've already talked about histograms. Bar graphs are the same as histograms, except the bars are separated. Dot plots, you're not going to see many of those, but I do want to introduce you to the stem and leaf display. So for the stem and leaf display, you will separate the data by a stem. It can be multiple digits. These stems are in ascending or descending order. Once you start, do not skip any stems until you have reached the maximum. The leaves or leaves are only one digit, and it may have to be rounded for the purpose of your stems and leaves not making an extremely large stem and leaf display. They are in the same order as the stems. And they are separated by space, not commas. So here's an example. This is 20 data pieces on the number of pairs of shoes someone owns. So 50, 13, 26, 50, 26, 30, 31, 13, 34, 27, 57, 23, 19, 30, 24, 49, 22, 13, 23, 15, 38, and 51. So since you can see it, these are all 2-digit numbers, I'm going to let my stem be my tens digit and my leaves be my ones digits. So I'm going to go into my calculator and put this data in the calculator just like I did before. I'm going to do second plus 4 to clear the list. And if you do this and take the time to sort the data, it'll make your job so much easier. So stat 2, sort list 1, and I can go back into stat edit. So now my stems are going to be my tens digit, my leaves are going to be my ones digit. You don't have to label those that way, but that just kind of tells you what I'm going to be putting where. My data goes from 13 to 57. So I'm going to start my first tens digit at 1, 2, 3, 4, 5, because that's my maximum. So then I start going through my actual data pieces. The one thing that a stem and leaf display does that a histogram does not do is it preserves each individual data piece. So you can still see what every data piece is in the graphical display. So again, we're going to keep things in order, but we are going to separate them by space. So I have 3 13s, I have a 15, and I have a 19. So you'll notice 1/3 is equivalent to the data piece 13. This is called a key or a legend, and it must accompany your stem and leaf display. Your stem and leaf display is a graph, so you also need a title. How many shoes? Moving on to the 20s, I have a 2, 2 3s, a 4, and 2 6s. Notice that I'm keeping everything in line. For the 3s, I have a 0, a 1, a 4, and an 8. For the 4s, I have a 9. And for the 5s, I have 2 zeros, a 1, and a 7. So if you were to turn that graph sideways, you can actually see that it kind of looks like a bar graph. Some people will also split the stems into highs and lows. So you may see that as well. So you would have 1 low, 1 high, too low, too high, and I'm just kind of give you an example of what that means. So the 3, 3, and 3 would go here because 0 to 3 would go in the low, or 0 to 4 would go in the low, 5 to 9 would go in the high. So then the 5 and the 9. So then for the too low would be 2, 3, 3, 4, and the too high would be 6, 6. And what that does is that just, if you have very few stems, then it can spread your data out a little more. And that ends section 2.1 and 2.2.